Sine and cosine transformations by Sarah Showers. What is sine and cosine functions? Sine and cosine are trigonometric functions. Sine and cosine functions usually represent the shape of a triangle. What sine and cosine graphs look like normally are shown right here, a cosine graph which is shown above and a sine graph which is shown below. They look very similar, they just start at different points. So basic parts of a sine and cosine function. There are two main parts of a sine and cosine graph that are different from other graphs. First, they have a period, which is how long it takes it to make one full cycle, meaning from from the highest point to the next highest point, or the lowest point to the next lowest point. They also have an amplitude, which is the distance from the midline, which is usually the x-axis, unless it is transformed to the top point or to the low point. So what are transformations? Transformations are something that moves or manipulates a graph, or actually it could also be a shape. In our case, we would be talking about graphs, specifically sine and cosine. So here is an original function, and as you can see, the red and green functions are a transformed version of the original function in black. So how do you transform sine and cosine functions? You transform a sine and cosine graph by altering the graph's equation. There are 5 main sine and cosine graph transformations. The first is a reflection, in which you would replace or change the a. Next would be a vertical shift, which you could change d. You could also change c, making it a horizontal shift, or otherwise known as a phase shift. You could change k, which would cause a vertical shrink or stretch to happen, otherwise known as the amplitude. And you could also do a horizontal shrink or stretch, which would change the period, which you would have to change a in that case. So first, reflections. So to reflect a sine or cosine graph, you have to put a negative sign where the a is located below. So an example of this would be on Desmos graphing calculator. So see, first in red, we have our original classic cosine function. If we add this negative right here in front of the cosine x, it flips it over the x-axis, or reflects it. So as you can see, there's your classic cosine function, and there it is transformed once you add the negative, which reflects it over the x-axis. So next, we could have a vertical shift. So vertical shifts move the whole sine or cosine graph up or down on the y-axis. To do this, you have to add or subtract the amount you want to move the function, where d is located below. So again, on Desmos, if you want to do a vertical shift, here's your classic sine function. After the whole sine of x, you either want to add something or subtract something. So if you want to go down on the y-axis, you would subtract something. If you want to go up on the y-axis, you would add something. So here, as you can see, I minus 4, which made it go down 4 on the y-axis. So let's say I wanted to move it up 5. If I want to move it up 5, I would put plus 5, and as you can see, the whole sine function is moved up 5 on the y-axis. So next we have horizontal shifts, otherwise known as phase shifts. Now these can be a little different. Horizontal shifts move the whole sine or cosine graph left or right on the x-axis. To do this, you have to add or subtract the amount you want to move the function, where c is located below. However, in this case, everything is opposite. If you want to go down 10, then you would add 10. If you want to go up 10, you would subtract 10. So this might be a little more clear in Desmos. So if you have our classic sine function in red, so let's say I want to move left 2. You would want to add 2 if you want to move to the left, which is more negative. So it's weird that you're adding, but that's how it is with horizontal shifts. So as you can see, the red goes to the green, meaning the green function, the transform function, is 2 to the left of the normal function. So let's say I wanted to go to the right, so positive 5. So in this case, it's opposite, so you would actually be subtracting 5. And as you can see, this purple one is moved from here all the way here. Let's delete this. So it has moved all the way from here to here. So it has moved left or right 5. So when you're doing the horizontal phase shift, you want to make sure it is in the parentheses, not outside of the parentheses like the vertical one was. So next we have a vertical shrink or stretch, which changes the amplitude. So you can shrink or stretch a cosine function, sine or a cosine function vertically. If you want to stretch it, you want a number greater than 1. If you want to shrink it, you want a number between 1 and 0. To do this, add that number in which you intend to shrink or stretch it by where A is shown below. This also changes the amplitude, meaning the distance from the midline to the highest point or the lowest point. So this is an example on decimals. So as you can see, this is your classic cosine function, or your parent function. And then if I added this 4 in front of the cosine x, it stretches it vertically by a factor of 4. So it gets longer. So let's say I wanted to shrink it, meaning it gets shorter. I could do, if you want it shrunk, you need a decimal. So let's do 1/2 cosine x. And as you can see, it then shrinks it vertically. So when I say it changes the amplitude, the classic amplitude for the parent function is 1. So now the amplitude for this is 1/2, or when this was 5, now the amplitude is 5 instead of 1. So that is your vertical stretch, and that goes in front of the cosine function or the sine function. So our last transformation is a horizontal shrink or stretch, which is also changing the period. So you can shrink or stretch a cosine function horizontally. If you want to stretch it, you want a number between 1 and 0. If you want to shrink it, you want a number greater than 1. Now, I know this is opposite from the vertical, but this is just another weird thing that's different. To do this, you add the number in which you intend to shrink or stretch it by to where A is now. This also changes the period, meaning the time it takes a function to make a full cycle. So an example of this is shown in decimals. So basically, I have my classic sine function. I put a 5 inside the parentheses. Now, since it's opposite, if you put a number greater than 1, it's going to shrink it horizontally. So see how everything gets tighter in this purple function than it looked in the red function. So let's say I wanted to stretch it. So with opposite this time, so let's do 1/2 x. As you can see, it then stretches it on the x-axis. Now this also changes the period because it will take longer now to get from this maximum height to this maximum height, or a full cycle, than it would have to get from this maximum height to this maximum height before. So when you're doing a horizontal stretch or shrink, you want to make sure it is in the parentheses, not right here like a vertical one would be. So let's do an example. What does this transformation equation have, and what will the graph look like? So if this is our transformed equation, what transformations occurred here? Well, we have a 1/2 inside the parentheses, so that shows you have a horizontal stretch by a factor of 1/2. And then you add a 5 outside of the parentheses, which shows you have a vertical translation up 5. So its graph, you would have to have a horizontal stretch by a factor of 1/2. And as you can see in this graph, it is being stretched. And then you also need to go up 5 on the y-axis to have a vertical translation. So that is also seen here. So example number 2, what equation would go along with this transformed graph? So when you're looking at this graph, you automatically see that from the red to the blue, it is shifted up 5. You also see that there's a horizontal shift to the right 4. So it starts here, the normal one, and then it is shifted this much, which is 4. So what would its equation look like? Well, you know you have to have a -4 inside the parentheses because you have a horizontal shift to the right and it's opposite, so you put a -4. And then you have a vertical shift up 5, which is normal, so you just add 5 to make it go up 5. So example number 3. So looking at this equation, what transformations have occurred? Well, first off, we see the 5 in front of everything, so that shows you have a vertical stretch by a factor of 5. Then we see that they added 2 inside the parentheses, and when it's inside, we know we're dealing with a horizontal shift, and since you added 2, we know that you actually go to the left 2. Then we see a -3 on the outside of everything, which shows it is a vertical shift down 3. So what would its graph look like? So first off, we know that we have a very big vertical stretch by a factor of 5, which as you can see, it is definitely stretched on the y-axis. Then we know we have a horizontal shift to the left too, which is shown here because it starts here and it ends up here. Then we also have a vertical shift down 3. And one way you can see this is your normal amplitude was 0, or no, not your normal amplitude, your normal midline was 0, and now your normal midline is -3, which shows it was shifted down 3. So example number 4, what equation would go along with this transformed graph? Horizontal shift to the left 1 because it starts here and it ends up here. We know we have a horizontal shrink by a factor of 2 because it is getting tighter together and more frequent on the x-axis. Then we also see we have a vertical shrink by a factor of 1/2 because it is much smaller on the y-axis than the original parent red function is. So what would this equation look like? We know we would have to have a 1/2 here because we have a vertical shrink by a factor of 1/2. We know we would have to put a 2 inside the parentheses because we're shrinking it by a factor of 2. Then we know we also have to go to the left one, which we know we're in the parentheses, and we're dealing with horizontal, so we would actually have to add 1. So a little review. Sine and cosine graphs can be transformed by altering the graph's equation. You can either have a reflection, a vertical shift, horizontal shift, otherwise known as a phase shift, a vertical shrink or stretch, otherwise known as changing the amplitude, and last, in red again, or a horizontal shrink or stretch, period. So if you follow these guidelines and remember what rules each different type of transformation have, you will be on your way to transforming sine and cosine graphs.